Thanks for the warm welcome. Yeah, I think I cannot do really magic, but let's try what we can do. Welcome to my talk about faster builds on Android from 2 minutes to 2 seconds. As already said, my name is Philipp Hofmann. I'm an Android engineer in Vienna. I work at a company, it's called My Sugar. Our mission is to make diabetes suck less, and I actually hope that you don't have to use our app, because if you have to, you either have diabetes or maybe somebody that you know has diabetes, which is actually pretty nasty. I want to start with why is build speed important? Let me just ask you, how often do you hit compile every day? Do you think you hit compile more than 10 times a day? Maybe please raise your hand. More than 20? 50? Okay, 100, maybe even more than 100? Somebody even 100, quite a few. I think it really depends on your development style. If you do test-driven development, you maybe compile a lot and run your tests a lot. But let's just assume you do it 10 to 100 times a day. And if you go from feedback of your code from 2 minutes to actually 2 seconds, this would mean that you actually save 118 seconds, which is quite a lot. If you just put this into perspective, that would be around 20 minutes for 10 builds, and up to 2 hours per day that you could save. That's quite a lot. And in a week, it would be 1.6 to 10 hours. I mean, of course, it's really hard to improve your build speed from 2 minutes to 2 seconds and to get your feedback pretty fast. But let's just assume you just reduce it by 5 seconds. And let's assume you do around 20 builds, and you are 10 developers in your company, and you just put it into a perspective for a week, it's already 2 hours. But if you actually do test-driven development or do loads of builds, like 100 or even more developers, it's actually 10 hours that you would save your whole developer group per week. So you can think of this reaching the break-even point pretty soon. So you could invest 10 hours, and you make your build faster by 5 seconds, which I think is actually easy to achieve. And then you would already hit the break-even point in 1 week or maybe 2 weeks, depending on how many developers you are. But I think that this reducing the waiting time has another effect, which you have to take into account. So what do you do when you have to wait 2 minutes for getting your feedback, or even just 20 seconds? So I get bored. Maybe I get my mind starts to wander. So it could be that I check my emails, I go on Twitter, I go on Reddit, I go on Facebook. No, I'm just kidding. I'm not going on Facebook. I go on Instagram because nobody's using Facebook anymore, I think. Or maybe you read some Medium article, which is way better. So if you have to wait, you lose focus. And I think focus for me as a developer is really, really important. And if I switch to multitasking, it's actually really, really bad. Because some people think multitasking, they can do it. But actually, multitasking is killing your brain. So there are studies out there which tell that multitasking lets your IQ drop significantly. That's like skipping a whole night of sleep or smoking weed. I know in Europe we're not allowed to do that. In some countries we are. In California we're not allowed to do it. But I think you don't want to call them being high. And also just this message bombardment that we get every day, like you get push notifications all over the time. If you just know there's an unread email, just you see the red flag somewhere, it can also reduce your IQ by 10%, because your head has to think about, hey, what was now coming, and it then have to switch back you to actually coding task. And this multitasking thing is especially really, really, really bad for men. And most developers here, as I can see, and are mostly men, is especially bad for us. So when trying to cook something at home, I really just focus solely on my task. And then my girlfriend maybe comes in, opens the door, and I say, like, come on, please shut the door. I'm just trying to fry an egg here. I really need to focus here. It's really bad for us. For us, it can even reduce the IQ up to 15 points. This would be like you being back to an 80-year-old, which I think is not a good idea that 80-year-olds write all our software. If you're interested more into this topic, you can check out this article. It's called "Multitasking is Killing Your Brain." But another argument for having faster builds is that slow builds also means that you have to wait longer for your tests. And this leads to test automation is a pain. So if I have a huge app and I just change some business logic in there and I just write a new test for it, reproduce a bug or something, and I have to wait for 2 minutes, that's not really nice for me that I write tests. So maybe I just change a lot of things and then just hit it once and then I try to look for the feedback. So I think faster builds lead to more frequent feedback, which also helps you to develop faster. So now we know why build speed is important. What am I tackling in this talk? So first of all, I'm going to show you how to measure your builds. And then like a quick win list that you can do to make your builds faster. That's for the lazy developers or maybe the developers that don't have much time. Just a quick list that you can check and it can really improve your builds drastically. And finally, I'm going to talk about modularization and build speed. So let's start with measuring your builds. One thing that really helps you before maybe measuring your build is that you can call clean on your project and also clean build cache. But if you really want to measure a completely clean build, please be also aware that in your user folder, you have a .gradle folder, and in there is also sometimes caching inside there. And sometimes when you call this on the Gradle console and call those two tasks, it could be that also something is still in the Gradle's build cache from your users folder. Scanning your build, basically measuring your build is basically pretty easy. You just have to add this flag scan. And what then happens is that Gradle compiles your project, and then afterwards you have to accept some terms of service. And if you say yes, it just says it's accepted, and then you're publishing it. So it actually uploads it to the Gradle site with some key, and then you just have to enter this into your browser. You have to enter your email address, and then they send you an email. I don't know why they make it that complicated, but I guess maybe they want to collect email addresses or something, or get some statistics. And then, when you click the link in your email, you get a nice overview. Who has already tried this feature? Just a few people. That's good. And what you can see in there is like the build time. It says it took around 60 seconds. And you can also see the tasks that were executed and how long it took. You can also click on the timeline to really see how long each task took, and really can take a deeper look into this. Also, what is cool is you have a performance tab, which helps you to analyze the performance, and there's a thing that's called settings and suggestions. And this already shows me here that I have an outdated Gradle version and that parallel execution was not enabled. More on that later. I will show this to you. If you want to read more about this, there's a good documentation on the Gradle documentation. You can check it out. And if you're not really comfortable with uploading your build to the Gradle site, there's also a feature from the Android developer documentation. It's called Profile Your Build. And all you have to do is just to use the profile flag. And what this does is then it generates an report in your build folder. It's just an HTML page. You can click on it. It's not as detailed as the scan feature, but it also has some information. So now we know how fast our build is. So first we measure, and then we optimize. And for me, that's always a loop. I mean, it doesn't really make sense to just start optimizing something without knowing then if it really improved the build speed. Now the quick wins to fasten your build. The easiest thing is update your tools. That's basically really easy. Just update Gradle. They recently published an article which shows benchmarks. So here you can see open source projects which they didn't change over time. And on the right side, on the left side from your perspective, you see it was in October 2018, and you see that with over time that the build speed slowly was getting faster and faster. For some project, it was even 44%. You can see it over there. For some, it was just 20%. But this almost comes at a cost of nothing. You just have to update it. Also, what you can see here is there was the median debug build time after changing some code. So how long it takes that you actually can debug. And from Gradle 2.3 to 3.0, it was actually 27%. With the other releases, not so much, but it gave you really, really huge build speed improvements with almost no effort. If you're interested in more about this, you can read this article that they recently published. Also, we should do is update the JVM. The JVM also has optimizations with new releases in there. I think you sometimes not really feel a difference, but it also helps to make you build a little bit faster. Also update Android Studio and the SDK tools, and also the Android plugin for Gradle. So just keep all those things up to date, and you will get faster builds with not having to change that many things. I'm not putting numbers here, like what it was for our project, because I think it's really always depending on which project you have and how big it is. So it's always really, really hard to find good numbers on this. Another thing is for you that you should do is use instant run. So for me, I think it's always very important when you change something that you get fast feedback. And instant run is really, really good for this. And especially if you deploy it to a device with Android API level 24 or higher, it's even more optimized. A few things that you can do in the Gradle properties is the first thing is caching. The cool thing about caching is when you run your Gradle builds, you have a lot of tasks that get executed. If you check the output, usually says like 84 tasks executed and maybe 70 already were up to date. And this is basically comes from caching. And each Gradle task has an input and an output. And if neither of those change, Gradle will not run it again. The cool thing is this is already enabled by default since Android plugin 2.3. So if you start now an Android Studio project from scratch, you already get this benefit just without doing something. What you can also do is when you use the Gradle Build Scan is if you click on the Performance tab, it also highlights you that if some tasks were not cacheable. That means that you can then dig deeper into it and try to find out why your tasks were not cacheable. What you can also do is you can define your own Gradle cache input and outputs. And how to do it, you can check this documentation. It's not so crazy complicated, but you need to get into it a little bit, and that can also help you to cache lots of tasks, which then again has a good effect on your build time. If you're using Kotlin, who is using Kotlin? That's half of it. You can also enable incremental compilation. It really also makes it build faster. It doesn't need to recompile everything. It just recompiles the files that you changed. And what you can also do is parallel builds. You just enable it. And this is a really, really good improvement if you have multiple modules, but more about that later. Next thing that you can do is you can create a build variant for development. So what I do here is I created a build variant that's called dev. And as you see at the resource configurations, I just copied the English language there and only the highest resolution. This means that he doesn't need to copy all the resource files, which is especially a slight improvement if you have loads of languages in there. But also you should really warn all the developers in your company that if they use this flavor, that they don't have other languages. I did it, and I once was changing a language to German or French, whatever, and I was wondering, why is this always English? And I was wasting 1 hour, even if I did it by myself. So it can be really, really a stupid problem to investigate. Also, when I started to improve the build time at our project, look for build configuration fields which are depending on time. So what sometimes is the case is that some Gradle tasks then kind of get not cached at all because the cache input or output is depending on the date, which means they always get invalidated. So you can just set this build configuration field to a static constant, and then some Gradle tasks won't be recompiled all the time. So those are just the quick wins. Update your tools, use instant run, enable caching, use Kotlin incremental compilation, use parallel builds, and build variant for development. Those are, I think, the most easiest things to do. If you want to get into professional stuff, you can check out this documentation. Most of the tips I have here are basically on this documentation site from the Android developers documentation, and also Gradle has a really good documentation how you can improve build speed of general Gradle settings. What you can also do is you can play around with the JVM memory settings. This is not so easy to play around with this, but it can also have a good impact. But keep in mind that this is always depending on which machine are you building. So if you have a CI, maybe you should have a different memory setting than on your machine. Don't set it just to default to what I have here. It might not work for you. If you want to know what all of those things are, you can check out this article. They really explain it very good there. How you can play around with those things, and it can really improve your build speed as well. So now to the third part, modularization and build speed. Here about modularization, I don't know if you watched Ben Weiss' talk previously. I'm not talking about modularization on an Android level, like with dynamic features, more on the Gradle library module level. So modules can speed up your build, but also can slow down your build. Especially with older Gradle versions, adding a new module sometimes put a little bit of overhead in there, but since Gradle 5, you don't almost have any overhead, and usually if you split it up, you have huge build improvements. But maybe check it first instead of just splitting it up into multiple modules. The first cool thing about multiple modules is you can build the modules in parallel. So here we have loads of modules. And when we start compiling this, what Gradle will do is it will start compiling the ones that all the others kind of depending on. And in this case, it's common and views. Those are the ones basically all the others depending on, and Gradle can now compile those two in parallel. After this, they're compiled, it can actually build other three modules in parallel, and when that is finished, it can Gradle can build again three modules in parallel. And I think this is pretty cool. I just give you an example. I had a small app with just one module. It was basically a very, very stupid app. You just tapped on it, and it was just calculating a level, so you could just go crazy and tap on it like 100 times, and then you level up. And when I compiled it, it took me around 30 seconds to compile it, and you also see over there on this line that basically all the modules, basically all the Gradle tasks were executed in one stream. So nothing was there in parallel. When I click on the Performance tab again and the Settings and Suggestions, what Gradle Build Scans is telling me is that I used an outdated Gradle version, and that also parallel execution was not enabled. So I optimized this. I updated Gradle and the Gradle plugin. I also updated Kotlin, and I enabled parallel builds and incremental compilation of Kotlin. And finally, I split up the code into multiple modules. And then, when I build it again, I go down to 21 seconds. So previously I had 29, now I have 21. And what you see here is that multiple Gradle tasks could actually be run in parallel. And I think this was basically the hugest improvement. I could have also measured step after step, but I didn't do it because, again, those numbers are not really comparable. But still, just playing around with it, I reduced the build time for around 25%, which is already a pretty good thing that I achieved here. Another cool thing is when you have multiple modules, is that you can just build what you need. So what you can do is you can just add a feature app. So it's actually an extra app that you would put into a whole project solution. And you don't have to compile the whole app, you just need to compile the feature app. And the nice thing with this is you only need to compile half of the modules. So you really, if you just want to try out a feature, you can iterate fast on it. Just put this into an example. I give you a taste of Bluetooth. We at MySugar, we have lots of Bluetooth devices that we integrate into our app because we need some diabetic data coming into the app. And what we did last year is basically we had our whole Bluetooth stack in the app, and we just extracted it into a library that we call Blue Candy. It's kind of sweet. And what we did there is we created a Blue Candy taste app for tasting our Blue Candy. And if I just do a change in the app and also run it, like just a simple change as just changing a string, like this. I hope you see it, it's in the middle. It took me around 18 seconds when I do it in the layout, or 7 seconds when I do it in the fragment. I was using instant run there, which is kind of okay. But if I do the same thing in the Blue Candy Taste app, which is actually pretty small and has almost nothing, you also see that we don't have all the fancy design there. And I do the same change there. It just takes me 6 seconds when I do it in the layout and 3 seconds in the fragment. Again, this helps me really, really to iterate way faster on this than if I compile the whole app. But what you actually want to do is when you build such a library as we did, you want to change something in the library and actually want to try it out. And what happens there is it basically needs to compile both things. So basically it needs to recompile Blue Candy and also the app. And this takes 65 seconds. It's especially annoying, especially for Bluetooth, it can be buggy and I want to play around with it a little bit because sometimes I don't really know what's happening. And I need to wait 65 seconds for the next iteration. Is really, really annoying. But if I again do the change over there and just run it in a taste app, which is pretty small, I don't have 65 seconds. I come down to 9 seconds. And I think that's a huge, huge improvement. And I can iterate faster again. So build just what you need. This helps you to build only the code you want to check. And you can iterate faster, therefore, on your feature modules. The third thing is splitting up your app into multiple modules also helps you to have faster tests. So if I have something in the app and I just change a test here, maybe I found a bug and I just want to add something new, it takes me around 15 seconds. And this is 15 seconds after all the caching kicked in and I already have compiled everything and I changed something, it's around 15 seconds. The first time it always takes me 60 seconds or maybe 80 seconds. But then if I have compiled it and cached, it's around 15 seconds. But if I do the same thing in this Blue Candy module, which has a few dependencies, but no Android dependencies, it's 4 seconds. So again, test-driven development for me is way more fun there. But actually, what I told you is I promised 2 seconds. So if I just put my business logic into a module, it's playing Kotlin or Java, and has no Android dependencies at all, then I can actually achieve this. What you see here is this is the sample app I showed you before. It's basically after the optimization, and it has only in there, it has a module, it's called entities, and it's really just Kotlin. It has one reference. I have some business logic in there, just some calculations of the levels, and I have a test, which just tests that stuff. So let's just run the tests. It's done in 1 second because caching was enabled. And it was already compiled before. I changed it a little bit. I run it again. Bam, it's just 2 seconds. So then fix it again, run it again. Again, just 2 seconds. So now I come from a feedback loop. If I have a huge, big app, which around takes me 2 minutes to build, I don't have any parallel builds enabled, I don't have caching enabled, I have outed a Gradle version, and I need to wait 2 minutes until I get some feedback. Now, if I really have a small module with all the things and caching enabled, I can iterate in 2 seconds intervals, which is pretty nice in my opinion. So the advantages of multiple modules are just, again, you can build it in parallel, as I just mentioned before. Build just what you need with the feature apps that you can add, and you have way faster tests. Also, what I want to mention here is if you split up into multiple modules and you have a really large application, you could parallelize all your tests in the CI, and you could run them in parallel, and then the whole CI workflow would run way faster. One point I forgot, and you get all the other advantages when you split up into multiple modules. You could argue that the architecture is better, you have view reusability, maintainability, solid principles and everything in there, which kind of pays out at some point. For example, Spotify has over 600 modules. There was a talk at a Droidcon in London. It was called Modularization, how hard can it be? And I recently spoke to Ty Smith, who's working at Uber, and I think he mentioned that they have over 1,000 modules, which is really crazy. So, to sum all of this up, I think that faster builds lead to faster development. So just remember what I mentioned before. If you cannot stay in the development flow and you always have to wait for 2 minutes, you kind of lose focus and you cannot stay focused and really get your job done. You might browse somewhere else and it really ruins developer productivity. Here again is the lazy or quick win guide that you can do with minimal effort to improve your build speed. Update your tools, use instant run, use Gradle caching, use incremental compilation of Kotlin, use parallel builds, and create a build variant for development. Also keep in mind that build speed modules can speed up your build most of the cases if you use the newest Gradle versions, but it can also slow down your build. Again, the advantages of multiple builds: build them in parallel, build just what you need, and faster tests. So what you want now to do is, you're now the superhero in your company when you come back home, and you say like, I'm going to optimize the build speed. But before you do it, you know that you have to measure first, and then you're going to optimize. And you're just going to measure it. You know, okay, now takes now 2 minutes, and then you're going to optimize it. And then I say, okay, let's check it again. Now it's at 1 minute and 30 seconds, and you go this around and round and round, and go completely crazy. And then you're the superhero, improve the build speed, and really helps all of your developers to be way more productive. My name is Philipp. Thank you very much for listening. And if you have any questions, please feel free to ask them. You also have here the slides, and below that you can also give me feedback. Thank you very much for listening.